Hello and welcome to the Multi-Level Health Information Modeling tutorial series.
In this section, we will explain how multi-level modeling overcomes current challenges in electronic health records. Multi-level modeling is a different way to develop software. It is a shift in the paradigm, or at least a huge evolutionary leap in the way that software is developed nowadays. The whole idea here is to bring context back to health informatics, something that is being tried, as we see in the previous sections, and it's not being achieved over the last decades. The principles of multi-level modeling can be summarized in this graphic. You have a computer scientist or a group, in this case of computer scientists, that have already defined an information model. And this information model is, in the case of multi-level modeling, a set of classes and its attributes and the relationship between those classes and other information that is required to allow the development of interoperable healthcare applications. And this information model is expressed as a schema. And then this information model is used by a healthcare professional, and this healthcare professional is the domain author. And using those pieces, using those tools that are provided by the information model, the domain author will define a library of healthcare concepts that are specific for his or her area of expertise. And this concept library will be built, of course, using the vocabulary of his and her own domain. And this is important because this is an important part of how the semantics of the information is kept. And then those two pieces, those two levels, so to speak, of the definition of the development of a healthcare application are adopted, are used, are implemented. So the information model and the concept library both will be used to develop the software. What is necessary is to implement the information model in software, and it is according to the information model that the persistence mechanism will be developed. And the concept library is important to define restrictions of integrity. Let's use this term that comes from relational theory, but it's okay. So the library of concepts that were defined according to the information model are important to define those restrictions to the information that will persist in the database. And at the same time, they will inform the development of the graphic user interface. And this is what we define as a multi-level modeling application. And then you can have different types of users. And here I'm showing healthcare professionals in the left, but I'm showing you in the right a family, because actually when I talk about healthcare applications, I'm not only thinking about electronic medical records inside hospitals. I'm thinking about any type of healthcare application. A blood pressure monitor that somebody has at home. The person can decide to develop his or her own personal health record to keep track of some information that they think is important for their health. And so the user is not only healthcare professionals. When you think about this broader ecosystem of healthcare applications, but then the users, they will input data using the graphic user interface. And so data instances will be created, and they will be persisted in a database. A simpler way to see it is think about the information model. The name that is given to the information model in multi-level modeling is reference model. So the reference model is like water. Water as this generic substance. That doesn't have. Of course, the water has some properties, but the water doesn't have a specific format. If you put the water on a vase, it will have one format. If the water is in the format of a drop, it will be completely different format. But this is essential. What's there in the hydrogen and the oxygen is essential. But then you can define constraints to your water, and when we think about drops of water, and they can be different, like we can see in this little graphic, they can be different from each other. Some drops will be bigger, some drops will be smaller, their formats will change a little bit. So what we are doing here is that we are taking this substance that is water, and we are defining certain constraints to this generic substance. And so when you do that, you are performing knowledge modeling, defining those drops of water is modeling the knowledge that you need, is defining your concept library. You can think about each one of those drops as concepts, and the set of drops that you develop is your concept library. And then you use those drops of water to create your garden. And the garden is your application with the graphic user interface that you're free to define the way that you think it's better. You can include decision support systems, business intelligence, routines. You can be as creative as you want in order to develop your application. It's important to make it clear that you are free to define your persistence mechanisms as well. Of course, since the reference model is object oriented, so it is important to be sure that your persistence mechanism should be object oriented, or at least no SQL. SQL databases are not the realm of multi-level modeling, and this is important to know. In the knowledge modeling, in the OpenEHR and the ISO 13606 specifications, they are called archetypes. In the multi-level healthcare information modeling, the MLHIM specifications, they are called CCDs. It's just because in our specifications, we like to give things descriptive names. That's why the specifications are called multi-level healthcare information modeling. Same thing with the knowledge modeling. The water drops, the knowledge modeling artifacts, are called concept constraint definition, which means that we are trying to define constraints to the reference model in order to build a certain data model for a given healthcare concept. Let me try to give you an analogy. You can imagine that the classes of the reference model are like pieces of Lego, and then you can have a certain variety of Lego pieces that you can use. And so you can make this analogy between the classes of the reference model and each piece of the Lego toy. And so let's say that you have those classes. You need to use those classes to build the concept of a helicopter. So look, the classes in the middle, the reference model classes, they are in the middle, and they are just generic classes. They are not defining anything. They don't have any context. They don't have any semantics. So they are reusable. But what happens when you are creating this little helicopter is that you are defining a certain combination of those classes, of those pieces, and you are defining constraints to those pieces. Those pieces will be connected to some other pieces, but they will be not connected to another pieces. Not all the parts of the pieces will be connected to each other. They will have a specific format, and that's what you do when you are building a CCD. So if you're modeling the concept of a helicopter, you need to pick up the right classes that you need, and you have to combine those classes in the right way in order to format this helicopter. But the helicopter is still made of those generic pieces. So actually, if another healthcare application is based on the MLHIM specifications, those classes will be then implemented in the reference model. So you can send an instance data base that was created according to this helicopter CCD. You can send that to the other system, and since the system is based on the same generic pieces, this information will be understood. And another system can use the exact same classes and build a completely different concept, the concept of a chicken. Those two systems can send data instance based on those two CCDs, the helicopter CCD and the chicken CCD, and both systems, since they are based on the same MLHIM reference model, they will validate the data extract that is coming from the other system.